mu of air, we have water and glass. Water, or the other way around. Okay, so if you have this, then you can say that the refractive index from air to water times the refractive index from water to glass times the refractive index from glass to air must be equal to 1. And this is the relation we derived. Okay, so this is how you are going to determine the unknown. The unknown is that find the refractive index from air to water. So we are actually looking for this. What do we have? The question has given us glass with respect to water, which is 9 on 8. What else were we provided? We were provided the refractive index of glass with respect to air, but we will need the refractive index of glass with respect to air. What they gave us, we'll need the refractive index of air with respect to water, but that's what they gave us. So we have this one. We are looking for this. We have this. This is 9 on 8 times. We will need this. Okay, air with respect to air, but we are given glass with respect to air. But there's one thing that we know, and that is the refractive index of the product of the refractive index air to glass by glass to air is equal to 1. So since this is what we need, we'll make this as the subject. Mu from glass to air is equal to 1 over refractive index from glass to air. Glass with respect to air. Let's put in our values. This is 3 over 2. And so it means that this will be 2 over 3. Refractive index from glass to air is equal to 2 on 3. Come and put it. So this is 2 on 3 is equal to 1. And don't forget, this is what we are looking for. So you make that as the subject. 2 would go into this 4. 3 would go into this 3. So you have mu of water with respect to air times 3 on 4 is equal to 1. When you make this as a subject, the refractive index of water with respect to air would be equal to, when you multiply through by 4 over 3. So 4 on 3. That's the answer. Please, are we okay? Are we okay?
Yes,
Yeah,
please.
please. Yes,
So,
please.
so it's, you see, it's not difficult if you understand. And then when they reverse it, you know, the products of the original and the reverse will be equal to 1. So when they mess it up, you can always rearrange and then apply and go your way. So simple as that. Okay. All right. So look for questions. I'll also look for similar questions and then just send it to you. But you owe me an assignment. Don't forget, which I will take. All right. So this is where we draw the curtains on today's meeting. Please continue reviewing this. Go over. If you have questions, forward it to me by WhatsApp. I will answer it so that we treat or heal ourselves until, same time Friday. In fact, this is where I do the bye.
Bye.
Bye-bye.
Okay. All right. Akovala,
You say there?
what do we do? Will you wait for it?
Yes, please.
Okay.
Say
Please,
there,
can I?
please.
Nanjemfa, you also wait.
And for the solution for the assessment.
Okay. I won't solve it for you. I'll just explain.
Yeah,
So
no
you.
problem.
Mhm. Okay. So can I clean the board?
Yes, please.
So the first question, you see, the question simply applies the concept of rotation. And in a concept of rotation, when you have a mirror, this is when the mirror is not rotated. Ado, are you there?
Yes.
Okay, there will be, is that there is a screen. There is a screen. So when the mirror is not rotated, it produces a spot on the screen. There is it. So this is the reflected ray, okay, coming from the mirror's original position when not rotated. Okay, now this mirror is rotated. The mirror is rotated. It's rotated through an angle theta. The rotation can either be clockwise or anti-clockwise, the same rule. So when rotated, it creates another spot on the screen. So this is the first spot, spot 1. And then when rotated, it creates another spot, spot 2. Okay, but on the mirror, so it is rotated through an angle theta. There is a second. Hello. Yeah,
Hello,
I know
please.
it.
Thank you.
It's better now.
Yes, please.
Okay. I'm looking for a marker. So this is the first reflected ray. This is the second reflected ray. For mirror rotation, we are not changing the source. The source is always there. But you know that when you rotate a mirror through an angle theta, the angle between the reflected rays would always be equal to 2 times the angle of rotation. So this would be 2 theta. Okay. Now, in one of the questions, you were asked to find the distance between the spots. When this is given, I think the distance of the first spot also from the mirror is given. So this distance is given. So if this is what I have, and I'm to determine this, then Pythagoras theorem, because I expect this ray to be perpendicular to it. So if the question is about the distance between the spots, knowing this angle, let's assume this is 15. Then it means this will be 2 times 15. So how do I get this? When I have this and the angle, using tan of 30 degrees, because this is 15, this will be 30, would be equal to S, let's assume this is H, the distance between the two spots, divided by the adjacent, which I'm given. maybe x. Therefore, h is equal to x times tan of 30 degrees. You are there. Okay. You are there. Let's see. Let me get what the question actually asks. In the first one, I'm reading. A ray of light is reflected from a mirror onto a screen, and a spot is created on the screen. The mirror is rotated through an angle of 13 degrees, and the spot moves up to a new position. Okay, so when it was original, it creates a spot S1. When it is rotated through an angle 13 degrees, okay, the spot moved up to a new position. And let's on the screen, let's assume this is S2. Okay, so this is the spot created when the mirror is not rotated. This is the spot created when the mirror is now rotated. If the distance between the mirror and the old spots, this is the first spot. Okay, the distance between the mirror and the old spot is 7.3. So this distance is 7.3. Determine the distance between the mirror and the new spot. Determine the distance between the mirror and the new spot. So here, the question is like asking you to determine the hypotenuse of this right angle triangle. Determine the distance between the mirror and the new spot. This is the mirror and then the new spot. So we are looking for a hypotenuse. You have the adjacent, you have this angle. The mirror is rotated through 13. So this will be 26. Okay, so if you have the angle, you have the adjacent, determine the hypotenuse. I think using cos of 26, you can get that. Please, are you okay? Are we fine?
Yes. Yes, Miss Ida.
Then the other question, I gave you a second question. This time, a ray of light reflected from a mirror, which is 750 centimeters from a screen. So the mirror is, okay, 50 centimeters from the screen. So if this is the screen and the mirror is here, the distance from it to it you are given. Okay. From a screen, create a spot on the screen. So when the mirror has its original position, it creates a spot on this, maybe S1. If the spot moves along the vertical, up. Okay, along the vertical through a distance of 620. So this time around, the question gives you the distance between the old spot and then the new spot, 620. When you have the distance between the mirror and then the spot, the old spot, through what angle in the vertical plane must the mirror be rotated? Through what angle in the vertical plane? So you have this, you have this. Through what angle in the vertical plane must the mirror be rotated? So you are looking for the angle between the two reflected rays. And you have the opposite you have the adjacent and you are looking for this. The appropriate trig ratio to use. Let's assume this angle is theta. Okay, theta will be equal to the opposite over the adjacent. So when you find theta, you have the angle through which the mirror must be rotated, because you know, if you get x for this, if you get maybe theta for this, the angle between the reflected rays, half of this will be the angle between through which the mirror must be rotated. Please, are we okay? Are we okay?
Yes, but Mr. Japis, when I look at the diagram, the part that you label as the new spot rather looks like the old one. I don't know if I'm not seeing it well.
No, I haven't drawn a new diagram. If I was using the old one and using that to explain to you. Okay.
Okay.
Just using that to explain to you. So just apply your understanding of the rotation of mirror, the first one, and you can easily figure out what to do here. It's not difficult, all right? So Deborah Akofala, just apply the first one and we'll be fine, all right?
Yes, please. Thank you.
All right, okay. So see you. Have a very good night, okay?
Okay, bye-bye. Good night.
All right. Bye-bye to all of you.